Hello everyone, welcome back to Industrial Statistic 1. I will continue our discussion on the introduction to statistics. In this video, I will start with the method of collecting data. So there are three basic methods for collecting data. Number one, we just use historical data. The historical data means we use data from the past. For example, uh, let's say that we want to forecast or we want to project the demand of a product, so that we collect the data from the year of 2019, 2018, 2017, and so on. And based on the data in the past, we try to project or we try to forecast the demand of the product in the future. So that's the use of historical data. Number two, we do an observation. One example of using observation is by, let's say that you are an engineer, and then you try to measure the daily temperature in your factory or in your workplace. Then you put a thermometer, and maybe for every 1 hour you record the temperature in your workplace or in your factory. And maybe you do this for a year, and then you're gonna have the temperature data in your factory for 1 year. Okay, so that's the use of an observation. And number three, the technique number three that we can use to collect data is by doing an experiment. An experiment means we are doing testing, but in doing that testing there are some variables that we vary its values, and we try to see the effect of the change in the value of the variable to the thing that we want to see. So I will give you an illustration in the next slide. Okay, so see the first picture. It is about what? It is about the exchange rate of US dollar to Indonesian rupiah. So this is the data from the past. Okay, so it is from August of a particular year in the past to July of a particular year in the past. So the first picture means we are using historical data, and the second picture over here, there is a guy who tried to measure, I think, the what is it, the speed of the wind. So that means he collect data by using observation. And the picture of a car right here, this means that they are using experiment in collecting data. Maybe they try to they change the design of the bumper of the car, and then they change the speed of the car, and then they want to see how bad is the collision between the car and the wall. So that's an experiment because there is something that they may change the speed, or they may change the material of the bumper of the car, and they want to see the effect of the change in on those variables, maybe to the safety of the passenger of the car. So that's the experiment. Okay, and based on the data, sometimes we try to develop a model. Okay, so a model means a representative of a real life problem. Okay, so there are several types of model. We may have a physical model, we may have a mathematical model, and also we can classify model into two types. uh, Type number one, we call it as the mechanistic model, and type number two, we call it as the empirical model. The mechanistic model, so the model is based on our knowledge on basic physical phenomenon. So we develop the model based on our knowledge on physics, based on our knowledge on mathematics, based on our knowledge in biology, maybe, and based on our knowledge on chemistry. So maybe we try to develop a model, and the basic law that we use to develop that model is the Newton model for the gravity, or the Newton law of gravity. So that's a mechanistic model. But sometimes when we are facing a problem, we try to model something, we try to model a real life problem, but maybe there is no a well understood mechanistic model that explains that problem. For example, we would like to know the relationship between the strength of a wire and the length of that wire and the height of the die that we use to produce that wire. So for sure, there is no a mechanistic model that can explain this. There is no model in physics that we can use in order to explain this. And to do that, the thing that we can do is we collect data. We collect data on the strength, the length of the wire, and the height of the die. And based on our observation, we try to make a mathematical relationship between the pull strength, the wire length, and the die height. So we develop this mathematical equation based on the sample, or based on the observation that we have. So this model, this mathematical model, we call it as the empirical models, because we develop the model based on the observation, based on the data that we have, based on the tests that we did. And why we need to develop the empirical model? Because there is no a mechanistic model. There is no a model in physics, chemistry, biology, or the model in science that can explain the problem. So that's why we develop an empirical models. Okay, so in order to develop an empirical model, we need to understand the what we call it as uh, the statistic inference. So remember that there are two branch of statistic. There is a descriptive statistic, and there is a statistic inference. So in order to develop the empirical model, we need to understand the inference statistic. Okay, so in this example, the model that that give you the relationship between the pull strength, wire length, and die height. We call it as a regression model. And you're gonna learn how to develop a regression model next semester in industrial statistic 2. So it will not be in industrial statistic 1. It will not be in this semester how to develop the regression model. But the basis of developing a regression model, we will learn that in this semester, in this semester and in this class. Okay, I think I'm gonna skip this slide. This is a very important topic, probability and probability model. So this is an example. Suppose a production lot consists of 1,000 laptops. There are 10 laptops are defective in the lot. Okay, so out of 1,000, there are 10 laptops that are defective. So among the 1,000, there are 10 laptops which are bad laptops. A sample of 20 laptops is taken from the lot. Question number 1. How well will the sample detect defective laptops? Number 2. How can we quantify the risk of making this decision based on the sample? Okay. So remember we have 1,000 laptops. So among the 1,000 laptops, 990 laptops are good laptops, and 10 laptops are bad laptops. And then we take a sample of 20 laptops from the 1,000, and we take that randomly. So the 20 laptops that we take as a sample, we may have bad laptops in that sample, or we may not have bad laptop in that sample. So when we don't have bad laptop in the sample, meaning that all 20 laptops that we have in the sample are good, we may think that's the we may think that all 1,000 laptops are good laptop, but they are not. Or maybe from the 20 laptop from the sample, we may have only one bad laptops, and the rest, which is 19 laptops are good laptop. And based on that, we may also think that okay, it is okay, one bad out of 20. So you may accept the lot, you may accept the 1,000 laptop. So now how well, how good will the sample detect defective laptops? It may not, or it may not detect defective. It may, or it may not detect defective laptops. So it depends on how many sample that we're gonna take from the lot. How many sample? What is the size of the sample that we're gonna take from the population, right? So for sure, the larger the size of the sample, the better the detection that we're gonna make. Okay. The best way that we can do is to inspect all 1,000 laptops. So that means that we do not take sample, we inspect the population, the 1,000 laptops. But that is not, sometimes that is not a good idea. Because what? Because you need to check one by one the 1,000 laptops. So that's gonna what? Gonna cost you time and money, right? So that may not be a good, they may not be a good idea also. So that's why we are taking sample. But what is the size of the sample? Should we take 20 laptops as our sample? Should we take 5 laptops as our sample? Or should we take 100 laptops as our sample? So in order to determine the size of the sample, we need to understand the law of probability. So how can we quantify the risk of making decision based on the sample? We can do the concept of probability. So the above problem in case number 2, we can answer that problem by using probability model. What is the use of probability model? We use probability models to quantify the risk involved in statistical inference. That is the risk in making decision. Remember, in case number 2, we need to make a decision. What is the decision? To accept 1,000 laptops or to reject 1,000 laptops? To accept the lot or to reject the lot? The lot. For example, if I am a consumer, okay, I am a consumer. So somebody send me 1,000 laptops. I buy 1,000 laptops from them. And then I need to inspect the lot. And then I decide that I'm gonna take sample. And based on the sample, based on the quality of the sample, I will judge the quality of the 1,000 laptops. Is there a risk for me? Yes, of course there is a risk. What is the risk? When I take the sample and all items or all laptops in the sample are good, what should I do? I will accept the lot. But maybe in the lot that I don't inspect, there are so many bad laptops in there. So that's my risk. What is my risk? Accepting a bad quality product. Okay, when my sample give me a signal that all laptops in the sample are good, right? But maybe from the 990 laptops that we do not inspect, maybe all of them are bad. So that's our risk, and that's what we call as the consumer risk. Okay, and there is another type of risk in this kind of case. We call it as the producer risk. What is the producer risk? The producer risk means the consumer reject a good quality products. That's your risk as a producer. So in order to quantify risk, we need to understand the law of probability and probability model. Okay, I think I'm gonna skip this one, and I think I'm gonna skip this one also. And this is gonna be the end of the introduction for industrial statistics 1. So this is the end of chapter 1, and on the next video we will start with the descriptive statistic. Thank you very much.